Good afternoon. My name is Felipe. Really glad to be here with you guys at KotlinConf this year. And today we're going to be talking about Kotlin Multiplatform. A little bit about myself. I work at Airbnb, as you might have noticed already, and been working with Kotlin and Android for quite a few years, and pretty big Kotlin fan, and got really excited with everything that was announced, as I'm sure everyone here was as well. And Kotlin Multiplatform was something that got me really excited, especially aside from anything else, just because it unlocks so many powerful things that we weren't able to do before. So I'm going to touch base on a little of the things that are possible now that we have that support. But before we move on, I want you to step back and say that make a slight correction to this title. When I first thought about it, I envisioned this talk as being targeted at JVM/Android and JavaScript as well. But it turns out that we don't have to be restricted at just that. And we can actually use Kotlin native to target pretty much any or most platforms that we can think of, not just JS and Android, JVM in general. So we can target macOS or Linux or even iOS. So this content here is really generic in the sense that it's not restricted to those two platforms. So just wanted to make that sure. Don't want to let you guys down, but it's just want to broaden the scope a little bit. So moving on, this talk is more of an overview of what you can and what you cannot do. And you might have seen the previous talk from Jake and Alec about SQLite. They touched on some of these concepts as well, on what you can do with multi-platform and how they migrated that library over to this new the new support. So you might want to check out that talk as well. We have a few more actually on this topic. There's another one later today by Martin, and there's actually 3 more multi-platform talks tomorrow. So a lot of chances for everyone to get familiar with this new functionality. It is still experimental, by the way, so it's not like officially stable yet. So of course expect some changes, and that's one of the things that I'm going to cover later on. But basically, I want to start off with setting the ground to make sure everyone is on the same page, right? So is it yet another cross-platform framework? What is it about, right? And what is different from Kotlin Multiplatform? What sets it different between this and React Native or Xamarin or PhoneGap? There's so many cross-platform frameworks, right? Like especially if you're on the mobile area, you've heard about all of them. Maybe you have you're already set your conclusions around them, or maybe you're a big fan, or maybe you're not a big fan. I know most people on mobile are not big fans of cross-platform, or so there just tends to be a very polarizing topic in general. So just wanted to clear that out first. And to be honest, Kotlin Multiplatform is quite different from most things you might have seen already. And that's one thing that I want to make it really, really clear. And it's ideal for business logic sharing, right? So it's mostly for, it's like one language that you can write once and ship anywhere. It doesn't make any assumptions about how you want to architect your app, right? It doesn't make any assumptions about your UI frameworks. Is it MVVM? Is it MVP? Is it UDF? Whatever, right? So it's a lot less opinionated than that. So you can't really compare them. It's basically apples to oranges. If you want to compare Kotlin Multiplatform to React Native, for example, which is something that's been really on the spot lately. So I work at Airbnb, and you might have seen, or may not have seen this blog post by my ex-fellow coworker, Gabe. But I do recommend looking. It's about our experiences with React Native. And if you haven't seen it, it's just a series. It's like 5 blog posts on the topic, and just covers a lot of the the reasoning behind why we did it, how it worked out for us. And there's a lot of stuff there that applies to basically any cross-platform framework you want to use. So a lot of the learnings could be even applied to Kotlin Multiplatform if you think about it in a more higher level way. So definitely check out that blog post. It's really interesting. And as I said, Kotlin Multiplatform is not React Native. I just want to make that clear. And it's not Xamarin, it's not PhoneGap, nothing like that. The way I see it, my personal perspective, is more like C or C++, right? It's like a language that can really be targeted for any platform or like many platforms. And it's not just restricted to one or just JVM, which I know that's how it started. And we all know it's like, now officially and blessed on Android, but don't think about it that way. It's more like a language that has tooling and support that allows you to ship it to any platform. So if you haven't heard about it, Kotlin native is actually one of the targets for multi-platform, which is why this is much more, it's not just JVM and JS, it's actually any platform that Kotlin native supports. So that's actually really exciting when I learned about it, which is not that too long ago. And then I decided to shift gears a little bit on the topic on like the overall idea for this talk. But so Kotlin native is actually, like I said, can target many platforms. And one of the things you could do is even use Kotlin native to target Android by shipping a shared library, for example, which is something that's really crazy. But to dig down a little bit more into how that works, there's basically 3 ways you could go about it, right? So you have a common module, right? So that's where your business logic is. Like I said, Kotlin multi-platform is ideal for sharing business logic, stuff that's not platform dependent, right? So that's where it shines, and you don't have to do anything crazy to do that. Like everything that's in the language you get for free, and you can ship it anywhere, right? But if you want to, in reality, we know that you want to either ship to one platform or the other. There may be many platforms, and hopefully that's what you want to do. And there's basically 3 ways you can go about it, right? You can use Kotlin C to target JVM or Android, and then you can use Kotlin 2.js to target the web. And you can use Kotlin native, which unlocks actually a whole new set of platforms. So starting with Kotlin C, you can, like I said, JVM and Android, pretty straightforward. That's how it started. If you use Kotlin native, then it gets a little more interesting. You can actually ship it as a dynamic library, or you can ship it as an iOS framework, or even as an executable, right? So the things you can do here are pretty, it starts to get really powerful. So like I said, you can even build a dynamic library. So think about a JNI library, like a native library that you use on Android. You can even use Kotlin to ship that. So you get like an SO package that you can load into an app and use that. There's probably not many reasons why you do that, since you can target JVM and Android directly. But it's something that you can do. And you can even build an executable for macOS or Linux or iOS, like I said. And lastly, last but not least, JavaScript. So you can target the web as well. Another option, by the way, you can even use Kotlin native to ship a to build it. So basically, Kotlin native is an LLVM backend, right? So if you're not familiar with what that is, it's a compiler. It's a compiler backend, so it generates a bitcode. So that in that bitcode is it's a LLVM construct that allows you to ship to any platform that LLVM supports. It's the same thing that C-lang uses for C++, for example. I'm not super familiar with how that works, the internals, but it's really powerful, and know that there's a lot you can do with that. So you can even ship to WebAssembly or cross-compile from that to JavaScript. So it's really powerful. Moving on, there's a few ways you can start using Kotlin multi-platform today. Most straightforward is use their plugins. So they have a set of plugins that you can use to use these features. So if you want to build a multi-platform shared library, you would use the common plugin. So it's always Kotlin platform something, right? So Kotlin platform Android, Kotlin platform JVM, Kotlin platform JS, and so on and so forth. So these are all the individual plugins you can use to have your project specific for each platform. And for Kotlin native, it's called Kotlin. I have no idea why they decided with this name, but probably has a reason, but that's what you would use for Kotlin native. I actually even learned recently that there's a new plugin that was released, I think, with maybe it's coming out with Kotlin 1.3, but you can actually use a plugin called KotlinPlatform Kotlin Multiplatform. I didn't have time to update the slides because that's pretty recent. So that just gives you a perspective of how fast this is moving. But this stuff all still works, and you can use it today. It's just that now you can have a single Gradle plugin that allows you to have all the different platforms in the single project. So you can have multiple source sets, and each one targeting a different platform. So moving on. If you're shipping a web project using JS, you might as well want to use the front-end plugin, which is really nice. You can use React, you can use DOM. So all the web APIs are available for you. It's really, really powerful. So definitely do check that out if you're planning to use it for JS. And the way you declare dependencies between projects is using expectedBy. So you might have seen that before. It's just a specific Gradle configuration that allows you to depend on the shared project. Right. So moving on, talking about the specific concepts of multi-platform. So these are the main two building blocks. So expect and actual. You might have seen this in other talks. It's basically the only and main thing that you can do that you can use to manipulate this project. And I'll just use an example of the stuff that you can do. So it's pretty powerful, and it's almost like a replacement for interfaces, but it's more powerful than that. I'll get into those details later. But you can expect a class to be implemented into a platform-specific project. So imagine you're building a e-commerce website, right? And they have an order object, and you have IDs, and you have amounts for the prices. And this is actually I took from a side project that I have on a related to cryptocurrency. So I have a coin pair there. Probably doesn't make a lot of sense in a isolated context, but it's just one isolated example. And this is how it would look like if you were implementing this class in the JVM project. So you just annotate all the fields with actual. You annotate the class name with actual, and then you can use the JVM APIs. In this case, you can use date times. You can use big decimals for the price amounts, so on and so forth. For another example, you can use, that's actually something that I was using in this example. So I have a few fields that use the decimal class, which is not something that exists out of the box, but I defined that as another class in the common module, and I implemented using typealiases, which is pretty powerful that you can do that. So you don't have to implement every single actual class that you need. You can use typealiases to basically assign that to an existing class. So we don't have to re-implement it. In this case, I can use the big decimal class in the JVM SDK to assign that to the decimal class that I have. And if I'm targeting JS, then of course big decimal doesn't exist because that's a Java class. I can just use a regular double and then just move on to that. Another thing you can do is expect on functions. So you can expect top-level functions to exist, and it just works out of the box. You can even expect extension functions, which is also pretty powerful. In this case, I'm trying to use an implementation for a function that gives me the current time in milliseconds, which is something you might have seen on Android. On Java, it's pretty straightforward. Use the system class to get that. But let's say you're targeting Kotlin native. You don't really have that available, right? So you actually have to use the C API to get the current time of the day and do a lot of math around there to get the actual milliseconds timestamp. So this works perfectly, and that's just an example of how you'd implement them in each platform. So stepping back for a second, and let's just think about why you'd use it, and what's the advantage of using expect and actual. And which is something that you could get done with an interface, for example, right? So Expect is more powerful in the sense that there's more you can do with it. You don't need any factory classes. You don't need any crazy. So factory is one main example, that something that you usually need to do with interfaces. And mainly the reason is because you cannot have a constructor in an interface, right? So that's something you can do with expect. So you can expect a class to implement a constructor, which is gives it a advantage over using interfaces. Another advantage is that all the implementations are known at compile time, which might be powerful because you can navigate back and forth, and IntelliJ has support for that as well, so you can click a button and see where all the possible implementations are for a given class, which is quite nice. Like I said, top level and extension functions are supported, and it's just more flexible overall than using interfaces. So that's an advantage. You don't have to use it if you don't want to. It's just something that's out there, and it's pretty useful. A few limitations for the common code specifically. If you have that in a separate project, which is something I do recommend doing, you cannot reference any platform-specific code, as you might have guessed. So you cannot use any Java APIs or Android or anything else. It's just Kotlin code, and that's it, right? So you cannot even have Java code in there. And it can also only depend on other common libraries. So it has to be pre-isolated. So figuring out how to clean up and isolate that code it could be challenging, especially if you have an existing project that you want to migrate. So that's something to keep in mind. So now that the basics are out of the way, I wanted to cover a more concrete example and like how I got more familiar with multi-platform myself. So it all started a few months ago, and it's all about side projects, right? So I have my main job, of course, that I do stuff on day-to-day, but reality is you cannot always play with new technologies at work, right? You have legacy code, you have dozens of people, and you cannot move as fast, you cannot experiment as easily as you can on your own stuff. So what I do personally, I have side projects, right? As I imagine a lot of you also do. So that's one way I approach this problem. Like, I want to learn about Kotlin multi-platform, and if you want to learn too, you should try that out on your own projects, right? So it's a great way to try out new stuff, and you don't have any stakeholders, you don't have any deadlines, you don't have any expectations in terms of quality. So that's the way I go about it. And in my case, I've been always a big fan of games, and always, like, I grew up playing video games, and I never really had an NES console. This is was pretty popular in the 80s. I had a Genesis back in the day, but I have so many good memories about playing games and having a lot of fun. I wasted hours doing that, and at some point after I grew up, got into computers and programming, I learned that you can actually emulate that in your computer, right? You can make a software behave exactly like a console hardware, which was pretty crazy and mind-blowing to me when I learned that. And by the way, this is my most loved game of all time, like just a parenthesis. And I haven't really implemented this, but the project that I worked on for trying out Kotlin multi-platform is this emulator. So it's available on GitHub if you want to take a look. And it basically implements a emulator for running NES games on basically any platform, right? So you can, I'm not sure if this is going to work, but you can actually already play a few NES games, and this is all running on Kotlin, and it's using a multi-platform project, and it's all over there. And my goal was to have this run as both a JVM project and also be able to run on iOS or even web. So that's my end goal. It's still in progress, so I won't be able to share a lot of learnings there, but it's working already, which just makes me happy. So diving deep into how the emulator works, that's not the main topic for this talk, but just to give you a perspective of how we approach the problem and how we solve the problem with using Kotlin multi-platform. The emulator is basically a console class, right? And that's basically all common code. It doesn't depend on anything, like any Java classes or anything. And it's composed of a few like top-level components. It's the APU, which is the audio processing unit. PPU is the picture processing unit, so that's the one who handles graphics, sprites, so it puts things on the right places. And the APU is the audio processing unit, like just processes the music and sound effects of the game. The CPU, of course, runs the instructions and has the register, so keeps state on everything that's going on in the emulator. And there's a mapper, which is seems like an NES construct that you can map like memory positions to different places, and every game has a different mapper. So that's not the point here, but just want to illustrate the overall architecture of this emulator. And for the purpose of this talk, we're worried about the audio and the video handling, right? So in this graph here, I have the audio buffer, the video buffer, and that's where things start to get tricky, right? So if you have a multi-platform project and you have if everything's in a common module, you can't really access the video graphics card, right? You cannot make any assumptions about where this is running. So basically that's where you draw the line. So I have a dotted line there in the graph where I represent like everything above it is common code and everything below it is platform code, right? So that's the way I approach the problem. And you basically have to figure out how you want to model the project in a way that makes sense for multiple platforms to use it. So another way to attack this problem is to have the video and the audio buffer also be part of the shared module. So they don't really have to be platform specific if you can isolate them from the platform, right? So you just try to move everything outside of the platform specific, and then just whenever you need to write to the audio and to the video buffers, then that's when you get to the platform-specific code. So zooming into the PPU, that's where things get more tricky. My initial iteration was to have a bitmap class. Of course, I was thinking in terms of Android, right? So Android has a bitmap class, and that's not something that you get on Kotlin. It's part of the Android SDK. So I decided to draw the line exactly there. So the PPU has a bitmap, which is basically a buffer, right, where it writes pixels to. So on every iteration of the emulator, it writes to a specific X and Y position and a specific pixel. So it's basically an RGB color. And my initial thought was to have that all be part of the platform-specific code and just have the PPU be isolated in the common module, right? And then from that point below, it's all Android specific. So it goes to a surface view and then goes to the graphics card, right? So that's how the first iteration looked like. So I had a bitmap class where I expected to have a constructor for specifying the width and height, and just had one method with setPixel for the coordinates and the color. And this was pretty much mapped exactly after the Android graphics bitmap class, which you may be familiar with. So that's how I went about implementing this. It's basically just a shim, right? It's a wrapper around the Android SDK's bitmap class. So it just literally just delegates all the functionality. And in fact, you could even simplify this by using a type alias. So as long as both APIs match, right? You can just use a type alias. So in this case, both our expect class, our expect bitmap class had a set pixel, and also the Android SDK's bitmap class also has that method. So it just matches nicely, and you can use type alias for that. So in that case, we can basically just use the default implementation and be done. But I realized that it doesn't have to be that way in the sense that, first, the bitmap class is actually pretty slow. Like the setPixel method actually makes a JNI call, so it's actually a native method under the hood. So it was quite slow for when testing the emulator. And if you're not familiar, the NES emulator runs at 1.79 megahertz. So that means it needs to run really quickly. You cannot allocate any memory. You cannot have any JNI calls. So I had to get rid of that. So I replaced that with an int array, which is a Kotlin class. So that could also be moved into the common code. So it basically removed the dependency from the native code. So in that sense, with that implementation, we can actually shrink the native surface and have that implementation be all part of the shared code and not have to worry about that. So then the surface view can pull the buffer out of the PPU and draw it to the screen. So we don't need that functionality. So this is what it ended up looking like. And again, this is all pretty Android specific. If you want to target JS, for example, then you need a canvas. And if you need a canvas, the API might change slightly. And I haven't really gotten to that part yet. So the main takeaway here is you kind of have to model your API depending on which platform you're targeting. But you also want to have some kind of shared abstraction, so you don't need to have your code be modeled after the platform, right? So in this case, it's more complicated because abstractions cost heavy performance cost, especially for implementing a emulator. So I couldn't really afford having more layers around it, so I ended up just putting like a straight-up buffer in there. But if you're like building anything other than a emulator where performance is not a huge issue, then you could probably just approach it having more layers of abstraction around it. So yeah, that was basically it. This implementation was faster. It was also made the API surface a little smaller. And takeaways from all this stuff, right? So Kotlin Multiplatform is still very experimental. It's changing a lot. So you can try it today. It works really well. I've been trying it for a few months, and it's great. It's a very exciting technology. Like I said, it unlocks a lot of new doors. So it can basically target a lot of platforms that you couldn't before, which is really powerful. You can benefit from the entire Kotlin community, right? So everyone already knows. Everyone here already is excited about the language. They are already using it. So everyone here could start doing this right now. You don't need to know anything else, anything new to do it. You don't need to know C or any native platforms. And tooling is really important. So knowing that JetBrains is behind this and they are building all the support for building multi-platform projects is also really huge. So I think that actually makes the complete difference, having good tooling or not. So it makes something really usable or completely unusable. And other than that, try to make no assumptions about your system architecture. So like I said, I was initially modeling after the Android API, but that's probably a bad idea, and you shouldn't do that. Try to put layers around it. Try to abstract your platform API so you don't have to be driven by how that works. This is not a platform. This is not a framework. It's just a platform. So sometimes it's a little complicated to distinguish between what is what, but my point is, like I said, this makes no assumption about how you want to design your code. So just do it however you would do otherwise. And yeah, like just Kotlin Multiplatform won't make any assumptions about how you want to build your app. This has a lot of potential. I can see really this growing into a full ecosystem in a year or two from now, as we have more common libraries coming out the door, like serialization, and I/O, even like reactive, for example. So that's something that's probably coming out in the next few weeks or months. In our case, if you work on a bigger company like I do, I work at Airbnb. We have actually almost 100 mobile engineers, and doing that kind of migration is not easy, right? So it's probably like a multi-year project. So that's something to keep in mind. Even though the technology is very exciting, it works, the tooling is very stable. It's a big change, right? So we have to redesign our entire system, isolate the common parts, make sure they don't touch any platform-specific APIs. So think about that. I do recommend trying it out tomorrow, whenever you have the chance, and as I did. And yeah, that's pretty much all I had. I'll open up for questions since we have a little bit of free time. But I want to just start the conversation and make sure everyone is excited about this as I am. And yeah, that's it. Thank you. Any questions? Sorry, can you speak up a little bit?
So percent-wise, how much of the code in your code base is shared and how much is platform?
OK, the question was percentage-wise, how much of the code is shared and how much is platform-specific, right? So for this project, I had this NES emulator, which it's quite unique in the sense that it doesn't really match most production systems you would build. I would say that probably over 70 or 80% of the code is part of the common module. And there's a caveat to that because it's not fully working with all like, for example, Kotlin native is not fully working, but the entire engine is common code. So only the part that handles audio and video is not like fully implemented yet. But basically, the entire engine is common, so you could ship to, like, I can see it being able to ship to JavaScript in maybe like a week, even less, because like everything's already there, right? So you just need to write your canvas, figure out the web audio APIs, and that's it. Then you're done. So yeah, it's pretty neat. A couple more.
Hi, thank you for the talk. Have you played with Windows? You mentioned iOS, Android. You also mentioned macOS, Linux.
I haven't, and that's a good question. I'm not sure whether or not Kotlin native is able to target Windows. Is that possible? Yeah. Yeah. So I haven't really. It's a great question. I think, like I said, as long as you figure out the platform-specific code, so if you figure out the Windows video API and the audio API, just plug that in, and that's it. So that's something we can definitely. I would take a pull request for that, for example. So yeah.
Hi.
Hi.
How would you deal with the difference between sort of the concurrency models between, for instance, JavaScript, the single-threaded event loop, asynchronous stuff, and sort of basic C, where you have to sort of native threads or whatever? What's the strategy to deal with the differences, those kind of platform differences, like the concurrency and synchronous, asynchronous stuff?
Yeah, that's another great question. So the way I would approach this is probably using coroutines. And I know that's something that's still a little bit in flux in terms of, like, especially regarding to Kotlin native. I think Andre mentioned that in the keynote about the shared mutable state, right? So as far as I can remember, you have to freeze everything that's accessible from multiple threads has to be frozen. So that means that you have to be really careful about how that works, and so that's also all platform specific, right? I don't really have a good answer for that, so I would definitely go with coroutines, and there's definitely you're probably going to run into a few roadblocks there in terms of like how exactly that would work for Kotlin native, but yeah, I don't have a good answer for that yet.
Hello, thank you for the talk. My question is not directly related to the topic. I wanted to ask, have you tried to play with Kotlin JVM to JS during React Native experience in Airbnb?
Sorry, let me see if I understand your question. If we tried Kotlin
to JS during React Native experiment?
We haven't, no. When we started playing with React Native, like trying out internally, it was about 2 years ago. It was 2016. I'm not exactly sure, but I don't think Kotlin to JavaScript support was released then. So it wasn't really an option when we started trying. But I think people are considering that today. Because so right now we basically deprecated React Native, so we're not really building new features with that. But we still have a lot of JavaScript code in the app anyway, right? Because like there's a lot of features that have been already implemented and are in production. But we could easily start doing that with I could see us doing an experiment with Kotlin to JavaScript as well. I'm not exactly sure if we have plans to do that, but that sounds totally reasonable to me. Yeah.
Thank you.
Yeah.
For me, it was not exactly clear how I structure the code, like the common code base? Is it a separate repo library you kind of get into your different platforms?
I can probably show you right now if you want to see. Let's see. Let's try some live demo here. But it's all the same. It's all the same repo, and it's multiple projects, right? Let's see. Android Studio is here, and I don't have it mirrored here, but let's see if I can show. But maybe can you see the screen, like the project structure there? Well, so it's basically one single project, right? And how can I mirror? But let me see if I can explain. So you have like common, right? You see common over there. It's a project, and you have Android, and then Android app is the app that depends on the common code. And there's like Android native lib, which is like a Kotlin native target, and that also everything depends on the common module, right? And it's all the same. It's all the same projects, just it's like sub projects, right? And I want to see if I can navigate this, but I don't know how to do this. Get it, Windows. 1 sec. Mirror. Okay. That makes it easier. Yeah. So there's there's a separate testing project that I don't remember why I separated it, but it's like a JVM testing, so you can like run the emulator on a JVM and not have to run it on like the actual Android emulator. So there's the Android app, presentation mode. So the Android app depends on the common module, right? And it uses expectedBy. It's just a regular Android app, and it uses Kotlin Platform Android, right? So it means it uses the Kotlin multi-platform support, and it targets the Android app. There's another project this is the Kotlin native, right? So same thing. expectedBy project common, right? So it's a Kotlin native project and uses the Kotlin plugin, so it makes it a Kotlin native. And it has two platforms. It has ARM v7 and ARM v8. So it basically it's a shared library. So you can use it on the Android app. So we actually have it here. If you look at JNI libs, I have lib, K, and ES. So this is basically a Kotlin native app. It's a Kotlin native shared library that ships the emulator engine as a shared library. So we can basically ship both implementations to so the same app can both have the JVM and the native implementation side to side, which is pretty interesting. But it could even like target iOS or Windows or whatever here. So that's basically the overall structure. And I think that's about it. Yeah. Yeah. Does that answer your question?
Yeah, more or less.
We can follow up afterwards if you want.
Yep.
No one else? Okay. Thank you.